Hello everyone, welcome to Kitchen Chemistry with Imabest. I'm Immaculata, also known as Imabest. On this channel, I explain chemistry using simple language, everyday examples, and step-by-step problem solving. Today we are starting organic chemistry, and I want to show you what organic chemistry is. Some people get so scared about it. No, organic chemistry is just very simple. It's very simple. So we have what is organic chemistry on the board. What's the first thing that should come into your mind when you hear organic chemistry? It's carbon compounds. And from the definition, organic chemistry is the branch of chemistry that deals with carbon containing compounds. So I will say organic chemistry equals to what? Equals carbon compounds. That's organic chemistry. Very simple. You should be asking yourself, why carbon? Why is it not other elements? Why is it not oxygen? Why is it not nitrogen? Why is it not sulfur? And why is it not hydrogen? That is what should come to your mind. Why carbon? So let's look at why carbon is the main element or the main atom in the inorganic chemistry. Carbon has valency of 4. What does it mean? That means, let's look at the structure. This is carbon. These are what? 4 bonds. This means carbon can easily bond with other carbon atoms like hydrogen, nitrogen, oxygen, or probably sulfur. So this is one of the properties. Carbon has valency of what? Of 4. And all these ones, other atoms cannot do this. They don't have 4 valencies. Sulfur and more atoms. There are other atoms too that can be bonded to carbon. And when carbon is bonded to hydrogen, if we have something like this, this is our what? This is our methane gas. That is carbon 1, 2, 3, 4. 4 hydrogen atoms. This is our methane. Methane gas. Another property is what? Catenation. That is the ability of carbon. That means carbon can bond with another carbon atom. Like it can make a long chain with itself. So we have like carbon to carbon. This is carbon bonded to one other carbon. You can also have carbon to another carbon bonded with 3 more carbons. You can also have another one which can also continue. So carbon can bond with another carbon. Yeah, they can make a longer chain. That is the meaning of what? That is what catenation means. Carbon being able to bond with itself. So this catenation can form what? You can have a long chain from here. You can have a long chain, a branch chain, a ring, and complex framework. So we'll be considering this. Catenation can form a long chain, a branch chain, a ring, and a complex framework. So This is a long chain. This is a carbon bonded to another carbon, bonded to another carbon. And each carbon atom must contain what? 4 bonds. If carbon does not have this, that means it's not correct. So this means we have hydrogens here. Carbon bonded to another carbon. Carbon bonded to another carbon. This chain can be longer than this. It can be longer than this. It shouldn't be just 3. I'm just considering my board. It can be longer than this. So carbon what? The catenation can make carbon form what? Long chain. This is the long chain. Branch chain. This is what? 1, 2. This is carbon. 1, 2, 3. We will get to naming. When we get to that, you understand it more. 1, 2, 3. 3 hydrogen atoms. 2 hydrogen atom. 1, 2. Another carbon. 3 hydrogen atoms. If you want to sum all this up, carbon is how many? 1, 2, 3. 1, 2, 3. C 3. How many hydrogen atoms? 1, 2, 3, 4, 5, 6, 7, 8. That is 3 plus 2 plus 3. 6, 7, 8. Hydrogen is what? 8. This is our what? Propane. This is our propane. When we get to naming, you understand. This is our what? This is our propane. Our cooking gas. Yes. Chemistry is everywhere. Organic chemistry is not something you should be scared of. You'll just be seeing it. It's everything around us. Yeah. Chemistry is everywhere. Even in the kitchen, everywhere you go, you see chemistry. Organic chemistry surrounds you. Yes. So this is propane. This is your cooking gas. We also have butane. That one has 4 carbon atoms. It's also a cooking gas. This is it. 1, 2, 3, 4. They're still long chains, yeah. This one, the carbon atom here will change to what? Will change to 4. And hydrogen atom will be how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is your butane. The name will change. When we start homologous series, you understand it better. For the beginners, this is butane. This is still your cooking gas. You can also find all these there's still hydrocarbon mixtures of hydrocarbons and organic compounds in petrol, your diesel, your plastics and waxes. Those things you use at home. Those things you are familiar with. So chemistry is just everything around you. So let's look at the branch chain. The same propane. This is propane. 3 carbon atoms. So 1, 2, 3. Same hydrogens. For now, we are using hydrogen. It can be bonded to any other atom. This is how many carbon atoms? 1, 2, 3. The same. Hydrogen atoms. 1, 2, 3, 4, 5, 6, 7, 8. They're still the same. It's just that the representation is different. The other one was a long chain, and this one is what? This one is what? A branch chain. So catenation can also form what? A branch chain. For the ring, we have it can form a 3-membered ring. Can also form 4-membered ring. Can also form 5-membered ring. It can also form six-membered ring, the one we are so familiar with benzene. Yeah, so sometimes you see something like this. It's the same thing. It's the same thing. All this place, the joints, these parts like this are carbon atoms. Yeah. Then we have, don't forget the hydrogen atoms. If you count, let's look at something. 1, 2, 3. It's not complete though. These bonds, the bonds here must be what? Must be 4. So this is just 3. That means there's one hydrogen missing. You count 1, 2, 3. One is missing. When there is no ring, I'll show you something. 1, 2, 3. Then 1, 2, 3. One is missing. Sorry. Then 1, 3. But in a situation where we have, if we have something like this, we know that these are our carbon atoms. You cannot put 2 hydrogens here again. No, you can't put it though. Because when you count it, this carbon now will be carrying how many? 1, 2, 3, 4, 5. That is wrong. In organic chemistry, is not correct. So what will be here is what? How many hydrogen atoms will be here? Just one. Just one. Just one, because of the double bond inside. Just one. Just one. Just one. So when you count it, this carbon atom now is carrying how many hydrogen? Is carrying how many bonds? 1, 2, 3, 4, which is correct. What I'm illustrating here is the ring, because of this catenation, that this can lead to what? A ring chain. We'll get to this. Don't worry about the naming and whatever. Just know that catenation leads to what? Can also form what? A ring. For the complex framework, we have so many structures like the docosahexaenoic acid, one of the omega-3 fatty acid that is present in a scumbia fish. Yeah, they are complex molecules. Let's see. This is it. So let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19, 20. So this is 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. You are counting from the carboxylic acid group. Yeah, this side, this is the omega-3 side. From here, this is 1, 2, 3. This makes it omega-3. There is a bond here. There is a bond here. So let's not go there, but catenation can form what? Complex frameworks. So this is it. So number 3 is carbon can form a stable single, double, and triple bond. That is carbon can form stable single, double, and triple bond. So the single bond, this is a single bond. This is a single bond. This is a single bond. Then the double bond, and triple bond. You will just be seeing it on the book. Organic chemistry is just very simple. If you follow it up step by step, you understand it very well. You should not be scared about it. So here, remember what I said, carbon must have how many bonds? 4 bonds surrounding it. If not, it's not correct. So here, how many hydrogen atom is here? It's supposed to be here. Here is what? Let's see here. 1, 2. How many hydrogen atoms? 1, 2, 1, 2, 3, 4. That's correct. 1, 2, 3, 4. That is correct. That is, you sum it. You don't need to. Okay. For beginners, I have to add the hydrogen atom. Yeah, that's it. So if you want to, how many carbon atoms are here? 2. How many hydrogen atoms? 1, 2, 3, 4, 5, 6. H6. So this is what? Our ethane. Taking us to the parent name, alkane. We will get to this when we'll be doing homologous series. So this is alkane because of the name, the ANA. Yes. Then for this, carbon to carbon double bond. Carbon to carbon double bond. How many hydrogen atoms is supposed to be here? This is already 2. So if remaining how many? 2. 1, 2. And this carbon is stable. That is okay. Then here again, 1, 2. How many is remaining? 2. That is complete. So if you want to count, each carbon atom has how many? 1, 2, 3, 4 bonds. That is correct. Organic chemistry, that is correct for carbon. Then another carbon, 1, 2, 3, 4. That is complete. So this is what? Still 2 carbon atoms. How many hydrogen atoms now? 1, 2. Let me add it for beginners. H and H. 1, 2, 3, 4. This is what? C2H4. This is our ethene. The name will change to EN. ENE. And will take us to the parent name, alkene. Alkene. We'll look at it more in our homologous series. Yeah. This is it. The same carbon atom but different hydrogen atoms. Then we have the triple bond, which is carbon to carbon triple bond. How many hydrogen atoms? Already this side is carrying how many? 1, 2, 3. So it's meaning just 1 hydrogen atom to complete it. You can write it this, it can be, the bond can be attached to anyway. It can be attached here. It can also be attached here. So 1, then let me add hydrogen. Then this side is 1, 2, 3. 3 bonds. How many is remaining? 1. This is what? For now, we are using hydrogen atom. It can be bonded to any other atoms. Don't forget that. So this is it. I like it this way. Or you place it up. So let's count it. Here, the same carbon atom. How many hydrogen atoms? 1, 2. Just 2. This is our what? Ethane. It's just the name. This is YNA. This is ethane. Taking us to the parent name. Sorry. Alkyne. It's just very simple. When you follow it up step by step, one by one, you understand organic chemistry. Very simple. It's not difficult. So number 4 is carbon forms strong but flexible covalent bonds. That means carbon to carbon and carbon to hydrogen bonds are what? They are strong enough to be stable, and also not too strong to prevent reactions. If you look at this, what does this mean? Carbon forms strong but flexible covalent bonds. They are strong but flexible covalent bonds. Let's look at some examples. So let's look at carbon to hydrogen bond. Let's take methane for example. Carbon to hydrogen bond. This bond is covalent. Yeah, that means they share electrons. There's no transfer of electrons here, and this bond is strong enough to exist stably at our body temperature, but are they strong enough not to break? No. They're not strong enough not to break. This bond is not too strong that it cannot break. This bond can break and reform. Yes, let's look at some examples. So let's look at ethane. There's two carbon atoms. This is ethane. Sorry. This is ethane. So this carbon to carbon single bond, this bond is very strong, and molecules here don't easily fall apart. They're very strong. Yeah, but this carbon now can rotate around the bonds. They can rotate. So that is what we mean by flexibility. That is being flexible. For a bond to be flexible means they can rotate, they can easily rotate. So let's look at why molecules should be flexible. Okay, this is ethane. Still the same molecule we used before. This molecule can rotate. They are flexible. They can rotate. These two carbons can move around the bonds. They are very flexible. So this molecule is not rigid like iron. They can rotate, they can bend, they can slightly bend. Yes, they are not rigid. They can move. So this allows molecules to change shape and fit into enzymes and probably drugs bind to receptors. Yes. So if molecules don't rotate, like if molecules are very strong, they are not flexible. That means drugs will not work and molecules will be so rigid, and there will be no breaking or forming of bonds. So that means life chemistry will not work. Organic chemistry needs controlled reactivity and not rigidity. So number 5 is carbon bonds well with many other elements like hydrogen, nitrogen, oxygen, and sulfur. This allows the formation of alcohols, acids, amides, amines, drugs, and biomolecules. That is the alcohols now. The alcohols are that is the OH. Anyway, you see OH, oxygen attached to hydrogen. This is an alcohol group. We have the methanol, sorry. We have methanol, we have ethanol, propanol, and we are so familiar with ethanol. Ethanol, that is the key ingredient in sanitizers and cosmetics. Yes, and it's also used as a solvent in perfumes and paints. You see, it's just everything around us. That is that is chemistry. So that is it. That is the alcohol. Then the acids. Acid, like we have this is the functional group. That is, it can also be written as this is it. Sorry. This can be ethane, ethane, propane. Once you are familiar with the ethane, the ethanoic acid, that is ethane is 2. How many carbon atoms? Ethane is 2 carbon atoms. That is, this is it. So it can be written as, yeah, 1 2 3 for this one. Here 1 2 3 for the carbon atom that is here. Then this, yeah, this is ethanoic acid, which is from where? The source is from vinegar. This is what we drink, vinegar, which we are familiar with. Remember the vinegar they gave Jesus Christ on the cross? Yeah, that is the ethanoic acid. So you see, chemistry is everything around you. It's not abstract. You'll be seeing it, and you are seeing them every day, just that you don't understand. The amides bond. So for the amides group, this is the general formula. This is it. You see an amine, that is NH2 attached to carbon to oxygen double bond. R can be hydrogen, R can be alkynyl. That is the 1 2 3. So this is CH2. Can be an alkynyl. It can also be an alkynyl. Yeah, that is when we have the triple bond. Yes, don't forget, we've mentioned that before. 1 2 3 4. This will be CH. It can also be an aryl group or phenyl group. Some people call it phenyl group. Still correct. That is the benzene ring. We also, sorry, let me do that. Write that one. That is the, we've mentioned something like this before. There is the benzene ring. This is it. The phenyl group or aryl group. So R can be all these things and more. And more. And the amines, this is just it. NH2. This attached to this, let me just still say R, because R can be methyl, let's say methyl, ethyl, and even a benzene ring, that is aryl group. This is when we have, if this is attached, let's say, yeah, this is aniline now. No, this is aniline. This is part of drug molecules. You see part of this in your, if you look at most of the structure of the drugs we take, you'll see most of this, because these are heteroatoms and their biological activities has been recorded. Like, there's so many of it, most especially the sulfur. You've been hearing of sulfonamide, very active. Their biological activity has been recorded: anti-malaria, anti-inflammatory, anti-cancer, so many of it, very powerful. Yeah, the sulfonamide group is this is the group. This is still a ring. This is carbon, so it can be a ring. Let me see, let me write it well. This is it. That is, remember, we're talking about carbon bonds, well, with many other elements. So this is carbon. We've mentioned that before. For beginners, can be putting carbons there. Can be putting carbons there, and don't forget the hydrogens. That is, if you cannot put 2 because of this bond, because this is already 1 2 3, so it's meaning just 1 bond to complete carbon. Remember, carbon has to be how many bonds? 4. Don't always forget that. So this is complete, and here we don't need any other bond again, because this is 1, the one that is attached to the sulfur atom, that is 1. This is 2, this is 3, and this is 4. This particular carbon is complete. Then here we have 1, 2, 3. We need 1 bond. 1, 2. Don't mind my writing. There's a bond here. So this is 1, this is 2, this is 3. We need 1 to make it 4. This is 1, this is 2, this is 3. This is 1, sorry. This is 1, this is 2, this is 3. We need 1 to make it complete. This is 1, this is 2, this is 3. We need 1 to make it complete. So this one is attached to you see this group, this sulfonamide group. This group is very, very active. Their biological activities have been recorded in anti-cancer, anti-inflammatory, anti-malaria. Yeah, this was my MSc project as anti-malaria, and we found one new compound that if that particular compound is worked on, you can have it as a drug molecule. We had a lead compound. Yes, it has been recorded as anti-malaria. So many of it. So this group, they are very, very active. Then we have the drugs and the biomolecules. If you look at your, like the quinoline, the chloroquine, which is from quinoline, yes. Your quinoline ring, you will see a nitrogen ring, nitrogen atom, sorry, a nitrogen atom in this ring. You know quinoline now, chloroquine, all those ones are derivatives of quinoline. So what brought about these explanations was just the fact that carbon is chosen as the main element or the main atom in organic chemistry. And the question was, why carbon? Why not other elements like nitrogen, sulfur, oxygen, or hydrogen? So from the explanation, we can see that carbon is the main atom in organic chemistry, and because it can form 4 bonds, it can form 4 bonds with itself, and can also form a long chain, and can form a single, double, or triple bond, and can as well form a stable compound with other elements. So what we will learn first is hydrocarbons, drawing and naming. So we'll start with hydrocarbons. I'll take this gently because of for the beginners, I'll take it gently. So the first thing that should come to your mind when you see hydrocarbon or when you hear hydrocarbon, hydro and carbon, hydrogen and carbon. Chemistry is simple. Organic chemistry is very simple and straightforward. Hydrocarbons, hydrogen and carbon. Compounds containing hydrogen and carbons. That's hydrocarbon. All the definitions will be saying, don't be scared. Hydrocarbons, it will look so abstract to you. It's not abstract. Compounds containing what? Hydrogen and carbon. That is what we'll start with. Those simple compounds till we get to the complex ones. So anytime you hear hydrocarbons, hydrogen and carbon, That's all. So if someone say hydrocarbon, you'll be thinking the person is speaking, this is so abstract. No, it's not abstract. So hydrocarbons is what? They're just compounds containing what? Carbon and hydrogen. That's all. So I'll be showing you how to draw their structures, write their condensed formulas, and also name them using IUPAC rules. So don't be scared. I'll take it gently for you to understand. So if you're ready to learn organic chemistry without fear, like, share, and subscribe so you don't miss the next lesson. Drop your questions in the comments. I'll answer them in my next video. Thank you for learning chemistry with me. I'll see you in the next video.